Given question, a bar CD of length 3 meter and weight 500 Newton rests on inclined surface as shown in the diagram. Find how close to N, C and D a load of 600 Newton can be placed safely. Mu is equal to 0.19 for all contact surfaces.
Let us understand given question with the help of diagram. Bar CD with length 3 meter and weight 500 Newton is given. It is placed on inclined surface. At point C, angle of inclination is 60 degree with horizontal, and at point D, angle of inclination is 45 degree with horizontal. Now we have to place 600 Newton load. Now we have to find out how safely we can place this load close to the point C as well as close to the point D. We will consider the first case. We will place the 600 Newton load close to the point C. Now if I place 600 Newton load, then load always acts in vertically downward direction. So it is nearer to this point C, so I will place here. This is the location of the point C and here is 600 Newton load. Now we will assume the distance of this 600 Newton load from this point D is equal to x. So we have to mention here this horizontal distance is equal to x. Now we know that weight always acts in vertically downward direction passing through the center. So on both sides of this 500 Newton load there is the distance which is equal to 1.5 meter. So here we have to place this distance. Now we will decide the motion of the point C as well as point D. Now when we place 600 Newton load nearer to the point C, then this end will try to move in the downward direction. So motion at the point C we will show in the downward direction along this inclined line. So this is the motion. Now at the same time, as this bar will tend to move in the downward direction, then at point D it tend to move in the upward direction along this inclined line. So we will show the motion of the bar at point D. So this motion is parallel to this inclined surface. Now this is the motion, this is the load placed at a distance x from point D. Then we have to draw the free body diagram. So we will first take the bar CD. So here is the NC and here is the NT. So we will first consider the motion is taking place in downward direction at point C. So there is the frictional force which will act in the opposite direction of the motion. So we have to show the frictional force which is parallel to the inclined surface. So I will show here the frictional force which is parallel to the inclined surface, and this frictional force is known as Fc because it is at the NC. Now normal reaction. So normal reaction is perpendicular to this inclined surface. So we have to draw one perpendicular line to the inclined surface, and this is known as NC, that is the normal reaction. Now if we observe at the same time at point D, this bar will move in the upward direction. So we have to show frictional force which is in the opposite direction and it is parallel to this inclined surface. So we have to show here at point D this frictional force, and this frictional force will be Fd, and normal reaction will be perpendicular to this inclined surface. So we have to show normal reaction, that is known as Nd. We have to show 600 Newton force closer to the point C and 500 Newton force at the middle point of the bar CD. Now if we observe, we have to resolve this Fc as well as NC, then FD as well as ND. So we have to resolve all these forces into two components, horizontal component and vertical component. So first, if I resolve this FC in horizontal component and then vertical component. So if we observe, this FC is parallel to the inclined surface. So angle with horizontal component is the same, that is 60 degree. So we have to mention here 60 degree angle. So what is the value of this horizontal component? It is equal to FC cos of 60. So we will mention here it is FC cos of 60. And for vertical component it is FC sin of 60. Now we will move for NC. So NC also we will resolve into two components, horizontal component and vertical component. So if I resolve this into horizontal component and here is vertical component. So how to decide the angle? Now if we observe, this NC is perpendicular to the inclined surface. And for this horizontal line, this vertical component is perpendicular. So the point of contact in between these two perpendicular lines, at this point of contact, the same angle is there. So we have to place here same angle is 60 degree. So how we can say this vertical component? It is NC cos of 60. NC cos of 60 and here is NC sin of 60. Now we will move to the next for FD as well as ND. So again we will resolve these components vertical as well as horizontal. So for FD I will resolve vertical component and here is horizontal component. Now this FD is parallel to the inclined surface and with horizontal line angle is 45 degree. So here same angle 45 degree. So how we can say this horizontal component? It is FD cos of 45. FD cos 45 and for vertical FD sin 45. Now we will move for ND. So ND also we have to resolve into horizontal and vertical component. So here is vertical and here is horizontal. Now this ND is perpendicular to the inclined surface and this vertical component is perpendicular to the horizontal surface. So angle in between these two is 45 degree. So same angle is in between these two perpendicular line is 45 degree. So again we have to show here this ND, that is vertical component, is ND cos of 45 and here ND sin of 45. Now we will consider equilibrium of this system and therefore summation of all vertical forces is equal to 0. Now if we observe, first is NC cos 60. So for upward direction we will use the positive sign. NC cos of 60 plus FC sin of 60 minus 600 minus 500, then minus FD sin 45 plus ND cos 45. Now we will solve this. Now this FC as well as FD we have to write in terms of NC as well as ND. Now coefficient of friction mu is given 0.19. So we can say that FC is equal to 0.19 NC and FD is equal to 0.19 ND. So we have to replace this FC as well as FD in terms of NC and ND. So cos of 60, that is 0.5 NC. Now instead of FC we have to write 0.19 NC. So sin 60 is 0.866 multiplied by 0.19 and we have to write here NC. Minus, now here FD. FD we have to write 0.19 ND and sin 45 is 0.707. So minus ND 0.707 into 0.19 plus here 0.707 ND is equal to, now these two minus terms are constant terms, we have to place to the right hand side. So it will become plus 600 plus 500, that is 1100. So if we will take NC as a common term as well as ND as a common term. So here we will take ND plus ND as a common term. So here it will become minus minus 0.707 into 0.19 plus 0.707. So when we solve this, we will get the equation in terms of NC and ND. 0.673 NC plus 0.565 ND is equal to 1100. So this is the equation number 1. Now we will take summation of all horizontal forces is equal to 0. So first is NC sin 60. So direction is towards right hand side. So we will take positive sign, minus FC cos of 60 minus FD cos 45 minus ND sin 45 is equal to 0. Now we will replace this FC as well as FD with 0.19 NC and 0.19 ND. So we have to calculate this. So 0.866 NC minus, now this cos 60 multiplied by 0.90, that is 0.1 NC. Here minus 0.1414 ND minus 0.707 ND is equal to 0. Now we can replace this minus terms for ND to the right hand side. So it will become plus. So if we take NC as a common term, then it will get 0.766 NC is equal to 0.8484 ND. So we get the value NC is equal to 1.107 ND. So this is the relation in between NC and ND. Now we have equation number 1. So we can replace this NC in terms of ND. So when we replace this NC in terms of ND, then we will get value of ND 838.79 Newton, and from this ND we can calculate NC, that is 929 Newton. So now from these two values we can calculate FC as well as FD also. We have to find out the value of X, that is the distance of the 600 Newton load from this point D. So we will take moment of all forces about this point D is equal to 0. So summation of M to the D is equal to 0. So how we can find out? So we know that force multiplied by the perpendicular distance. So if we take the 600 Newton load, now if I move the compass about point D with the direction of 600 Newton load, that is in the downward direction, then here is this anti-clockwise direction. Now for this direction we will consider the positive sign. So we will take plus 600 multiplied by perpendicular distance. So this distance is X, plus this 500 into, now this also anti-clockwise direction, so plus 500 into perpendicular distance, so we know that it is 1.5. Then we will move to the next, that is FC sine of 60. So for this FC sine of 60, if we observe, it is in the vertical direction, that is vertical upward direction. If I move the compass in vertical upward direction, then here is the clockwise direction and we have to use opposite sign, that is negative sign. So minus FC sine of 60, and what is the distance from this point D? For this point C, it is 3 meters. So we have to write here perpendicular distance 3. Now next is NC, NC cos of 60. So it is in the direction of vertically upward. So it is having clockwise direction. So minus NC cos 60 multiplied by 3. Now if we observe, this horizontal component of FC and NC are along this bar CD. So we cannot take because this perpendicular distance is 0. Now the forces acting at point D is also equal to 0. So when we solve this, there is only one unknown term X, because value of FC we know we can calculate from NC, because FC is equal to 0.19 NC and NC we have calculated. So only one unknown term X, and X is equal to 1.877 from this point B. So its unit is meter, because all the units if we observe is in meter. So value of X, so we can place the 600 Newton load at a distance of 1.877 meter from this point D, because its X is the distance from the point D. Now we will move to the second case. We have to find out the distance of 600 Newton load from point D when it is placed closer to the point D. So we will plot here the 600 Newton load which is the closer to the point D. Now weight always acts in vertically downward direction, and from point D we will consider the distance is x. And we have to find out this distance x. Now we will decide the motion of the bar at point C and at point D. When 600 Newton load is placed closer to point D, then bar will tend to move in the downward direction at point D along this inclined line. So the motion is in the parallel direction to the inclined surface. As this bar is tend to move in the downward direction at point D, then at point C it tend to move in the upward direction. So we have to show the motion in the upward direction. Now we will show the free body diagram. So 600 Newton load we have to place in vertically downward direction. Then 500 Newton load is at the middle point. It is also in vertically downward direction. Now at point C, if we observe motion is in the upward direction. So frictional force we have to show in the opposite direction parallel to the inclined surface. So frictional force is in the downward direction. Then normal reaction should be perpendicular to the inclined line. So we have to show here, this is the normal reaction. So here frictional force is Fc and normal reaction is Nc. Now in the same way at point D, motion is in the downward direction. So we have to show frictional force that should be parallel to this inclined surface, and it is in the upward direction. So it is Fd, and normal reaction should be perpendicular to the inclined surface, and it is Nd. Now we will resolve these inclined forces into two components, horizontal and vertical component. So how to resolve this Fc? So one component is horizontal and other component is vertical. Now this Fc is parallel to the inclined surface. So angle with inclined surface with horizontal is 60 degrees. So this is the horizontal component. Here the same angle 60 degree. Now NC is perpendicular to the inclined surface, and for this horizontal line vertical component is perpendicular to the horizontal line. So angle in between this NC and this vertical component is also same, that is 60 degree. So we have to show here. Now we will write the value of the component. So for horizontal component Fc cos of 60, and for vertical component it is Fc sin of 60. Then for this vertical component of NC, it is nearby to angle 60 degrees. So NC cos of 60, and here NC sin of 60. Now in the same way we will resolve Fd and Nd. So if we resolve Fd into two components, then this Fd is parallel to the inclined surface and with horizontal line, that is with horizontal component, angle is 45 degree. So we will write here value for horizontal component Fd cos of 45, and for vertical Fd sin of 45. Then we will resolve Nd. So Nd also into two components, one is horizontal and second one is vertical. Now for this vertical, if we observe Nd is perpendicular to the inclined surface and this vertical component is perpendicular to the horizontal surface. So these two are the perpendicular lines to these two surfaces, making an angle 45 degree. So here also same angle 45 degree. So how we can write the vertical component? Nd cos of 45, and this horizontal component Nd sin of 45. We have to show this distance, and this distance from this point D is x. Now we have to solve by the same method as we have used in the previous case. So we will have to consider the equilibrium of system, and then the summation of all vertical forces is equal to 0. So when we consider summation of all vertical forces is equal to 0 and summation of all horizontal forces is equal to 0, then we get the value of NC as well as ND. And from that we can calculate the value of FC as well as FD. And then we have to take the summation of moments of all the forces about point D is equal to 0. So when we take summation of all these forces about point D is equal to 0, then we have to use only these vertical forces, that is NC cos 60, FC sin 60, then 500 and then this 600, and we have to take the moment about point D. Then we have to find out the value of X. When we solve, we get NC is equal to 619.67 Newton, ND 1057.82 Newton, and the value of X minus 0.237 meter. Now this is the important. So if we observe for this question, we have assumed the value of X, that is this is the positive X, from this point D up to the 600 Newton load. So this is the positive value. Now from point D we have placed 600 Newton load towards the left hand side, and then we get this positive value, but here we get the negative value. That means if I take the value of X in the opposite direction, that is towards the right hand side, then here we will get the minus X, and that is equal to 0.237 meter. That means we can place safely the 600 Newton load beyond this point D at a distance 0.237 meter. That means it is not possible. So how we can write the answer? We can write the answer, we can place 600 Newton load safely in between the point D, that is at this point D also we can place this 600 Newton load up to the distance 1.877 meter from this point D, because in the previous case we have closer to point C, the distance is 1.877 meter from this point D. So what is this safe points? That is here up to 1.877 meter, that is this point up to this point D.